Thanks so much for coming. My name is Jenny McLaughlin. I'm a senior platform architect at Pivotal. And today we will be talking about Neo4j and Cloud Foundry, from Speedy app development to Speedy graph database. All right, so now let's talk about what we really want to talk about, which is what developers love. We love our softwares, right? Developers? All right. We love it so much, and we wanted to give it to the world. And we want to get quick feedback, make changes, and give it back to the world. So ideally, we want to be able to deploy new features, let's just say, daily to production. Maybe you want to do hourly, or maybe you want to be like Amazon. They deliver their new features to production every 11 seconds. But let's just say daily. Think about what that would let us do, how our business delivered values. It's all about that faster feedback loop, right? And we also want us to everybody focus on outcome instead of individual activities. So instead of saying, let's build that web page or adding schemas to our database, let's just say, I want all the passerbys at Times Square tonight to sign up that weekend special program. So I want my teams to be really aligned with business outcome, kind of like DevOps going. I want my softwares to be loosely coupled so I can make components out of my applications. I can update them independently so I can go quicker. And of course, data is everywhere. User-generated data, machine-generated data, the velocity of the data, the variety, and volume of data just come into organizations like phenomenal speed. And it just doubles its size every 2 years. So we want to be able to store and retrieve the data efficiently, and we want to be able to have some database to ingest the data with different kinds of forms without compromising performance. I want to have my middleware, hardware, everything to be self-service, automated. Because if I have to go through the manual process to spin up VM and WebSphere, things like that, I'm not going to be able to do my daily deployment anymore. And I want to be able to scale things out and back in quickly and hopefully for free. I want to be able to upgrade my software with absolutely no downtime, because Facebook and Netflix, they never have downtime, right? Neither should we. We have customers globally. Plus, it's just really dangerous to have that change window in the middle of the night. When folks are tired and grouchy, we tend to abort our effort if something goes wrong. So let's do upgrade in the middle of the day, where everybody is happy, we're at our peak performance, and if we have to roll back, that's okay. We do everything in a no downtime way. I want my applications to be highly available, resilient, and any failing components can be automatically resurrected. But in reality, things aren't that easy. Sometimes deploying applications can be very slow. Think about a typical app dev team in an organization. We usually support many applications, right? And now marketing has this new idea, and they want us to work on it until it's done. Of course, a software is never done. It's just a release. But at least until it starts to get in front of customer, we're either making money or we're losing money. Between idea to production, we have to go through planning and development and testing, deploying, and monitoring the application in production. So that can take probably months. So on the development side, we decided to do Agile. And we do some continuous integration, Scrum, daily stand-up, and we do unit testing, and developers checking the code and kick off the build. If it passes, great. If it fails, we will get a notification say, hey, you broke the code and go fix it. So that's pretty standard, but the problem is it's too narrow. right? We still have separate QA team who is going to do testing in the integration testing environment, functional testing environment, user acceptance testing environment, performance testing before we go to production. And for each testing environment, we have to spin up the VM, install OS and WebSphere Tomcat, or if you're in Windows world, that would be IS server, network, F5, DNS, certificates, hook up the backend database, and some configuration, deploy the code, and do the testing. And in fact, we have to do this for every environment. And the funny thing is that if somebody is doing a security patch or upgrade, and now I can't do testing anymore. Or if somebody accidentally changed my artifact, my jar file, or configuration, or the security policy on Windows Server, and now the environment is useless, right? I mean, we've all seen this. Becomes inconsistent and corrupt and dirty, just useless. What's the point of testing? So even though we have Scrum on the development side, the whole process is still a little bit waterfall, right? So now we have water, Scrum, fall, which still takes months from development to deployment. So that's pretty frustrating. And from the operator's perspective, things are not necessarily better either. Still can be slow. For patching and upgrading, someone has to write the scripts, and somebody has to apply the scripts in different environments. And most likely, that's going to involve outage. And operators has to consider, OK, there's no single point of failure, so we have to set up clustering. We have to figure out how to scale and make it highly available and consider security, those kind of things. So the problem is that all these things, to me, is just not much of business value, right? If you think about it, it's just kind of below the value line. Because at the end of the year, your CIO is not going to pat your shoulder and say, oh, great job patching that server, right? So with all the frustrations, there got to be a better way. And we want to be better at this. We want to iterate fast. Of course, everybody knows cloud native, right? It's kind of buzzword going around for several years. And it's not about running your workloads on someone else's data center. It's really about deploying your applications or services in a totally different manner by significantly reducing that development to deployment cycle time. So it has three components: continuous delivery, DevOps, and microservices. They're necessary components, but they require a cloud-native platform to glue them together. So going back to our story where we push this idea to production, continuous delivery is that extension of continuous integration. It's all about having that consistent automated platform where each and every environment is as close, identical as possible. So instead of having that corrupted environments, now we have an automated platform where everything is automated. The VM should be automatically spin up, and OS should be automatically installed, and middleware, and network, and all those things. So when developers check in the code, it's going to kick off the build, an artifact will be created, right? It will be automatically promoted to integration testing environment. Of course, you still got to write your test scripts, but that can be automated as well, right? You run your test scripts and pass, everything is automated, get promoted to functional testing environment, and past that, go to user acceptance testing environment. There will be pause here because we need human interaction here, but at least your environment is ready. So your users come in and test it and hit that green button, is going to automatically promote it to the performance testing environment. And you can either automatically promote to prod, or you can let your prod owner decide at that point, another pause. But at least everybody will have high degree of confidence before a new release goes to production that this is going to work because it has gone through all these steps. And DevOps is that extension of the Agile team, basically brings devs and ops together. So we are responsible for the application, right? It takes the overall ownership. The team has the overall ownership, therefore they're going to do what's the best for the application, and consequently what's the best for business. And this automated platform, cloud-native platform, enables DevOps more than anything else. It really helps remove the friction. Microservices are loosely coupled services with bounded context. So it really helps improve speed to market, scalability, and resiliency. Each microservice interacts with each other through certain type of APIs, usually language agnostic. And each microservice has its web tier and data tier, service tier, data tier, and backend database. So if they have to make a change, think about it, is everywhere, everything is within the same team's control, right? So the team really meet their own business needs and control their own destiny. Like we mentioned earlier, we need a cloud-native platform to glue all these components together, and Pivotal Cloud Foundry is that structured cloud-native platform. It is infrastructure agnostic. As you can see, Cloud Foundry runs consistently across different IaaS, whether it's vSphere, OpenStack, AWS, Google Cloud, or Azure. And there's this layer called BOSH. It's an open source tool. It's all about deploy and manage distributed systems. So BOSH interacts with cloud, different clouds through Cloud CPI. And it really takes care of a lot of operational challenges, things like provisioning and monitoring and updating and patching. So if there's any failing processes and components, it's going to resurrect back up automatically and restore it to the correct state. That is powerful because you can continuously deliver all these distributed systems from version 1 to version 2 to version N without any downtime, right? And also, you can patch things on the fly. Everything just goes smoothly, and that's just the operation control. Very powerful. So now we have the ability to deploy and manage distributed system. And the first distributed system is right here, Pivotal Application Service. This is pretty much, everyone knows about Cloud Foundry, where developers just do CF push and push their code to Cloud Foundry. And another aspect is PKS. Pivotal Container Service, K refers to Kubernetes. It's enterprise scale of Kubernetes. It makes cluster provisioning a matter of minutes operation, and also seamless patching and upgrading. So if you have prepackaged applications, third-party vendor software, or some backing services, you can let PKS manage those things for you. Pivotal Function Service brings functions to the Cloud Foundry context, right? It really allows you to do functions and events and behind your firewall, in the enterprise, right? Not in public cloud. So you can start tapping those network events, database events, and instead of using those random shell scripts, now you can turn them into functions, right? Supports multiple language. Of course, they can run in different clouds. And the last pillar here is Pivotal Services Marketplace. This is where you can connect your applications with different backing services. And speaking of backing services, in Cloud Foundry, we're talking about data stores, messaging queues, and caches, things like that. So there are two types of services. One is BOSH managed, and the other one is externally managed. Remember, we talked about how BOSH is all about deploying and manage a distributed system. So BOSH can manage your backend service, right? And if you don't have that service to be BOSH managed, it's something else is managed the life cycle. And we do this by using this important and pretty simple API called Open Service Broker API. So the service broker is just going to reserve all the resources for you and give you connection information. And from the developer perspective, it's just an endpoint. So now we got to look at some of the database services, data stores, right? Pretty much all developers were familiar with asset transactions from working with relational database. And it's just relational databases requires us to do, create logical models and force the structure into a tabular physical model. And with foreign keys and join tables to reflect those relationships. Joins aren't that bad if you just have 2, 3 hops, but if you have lots of hops, and that can really jeopardize your performance, and sometimes the results may never get fully calculated. So if you look at these tables, if we want to know what products did Alice purchase, probably a couple of hops, joins, and we can get results. But if we want to ask the question, which customers bought strawberry ice cream? And that can be an expensive query, right? So relational database is just, another aspect is not meant to be able to keep up with the quick business change requirements. Because it's just rigid and data modeling is complex. So if you need to have a huge amount of data and your business requirements constantly change, definitely graph database is a better choice because it put the data relationship in the center, right? And if you want to add a new node or new relationship to an existing graph, it's not going to impact the performance much. Queries are very efficient, even though some queries are deep and complex. And Neo4j definitely lead the effort in this space, right? And in terms of graph processing and graph storage, especially if you want to run graph database in production, Neo4j Enterprise Edition is the way to go. Not only does it provide developers design and development tooling, it gives operators all these benefits in terms of availability, performance, security, monitoring, etc. So let's do a demo. So what we're going to do here is we are going to have the Spring Boot application called Movie Graph. By the way, Spring Boot is a Java framework. It's a very opinionated way of building microservices, in case you're not familiar. We're going to push it to Pivotal Web Services. This is Pivotal's public cloud. It actually hosts like more than 60,000 applications. We're going to use user-provided service to connect to Neo4j Enterprise that's spin up on Google Cloud. All right, so let's look at our application. I have this movie, Java Spring Data Neo4j application. And I want to make sure it runs on my local environment first, right? I'm just going to say maybe in Spring Boot run. So it's up running on port 8080. If I go to localhost 8080, I see my movie graphs here. Now I'm getting ready to push it to Cloud Foundry. But remember, we have to have Neo4j running cloud somewhere. We wanted to run it on Google Cloud. So I'm going to spin up a Neo4j Enterprise in Google Cloud. I'm just going to say launch on Compute Engine here. select a project. Just few parameters, the name, the zone, and what kind of machine type, how many nodes, minimum 3 nodes. And if I hit deploy, in a few minutes, a Neo4j Enterprise console cluster is going to be deployed. Since I've done this before and I don't want to create another one and burn money here, so I just want to show you the results really quick here. So basically, it just gives me the connection string, which here we go. I created previously. This is my Neo4j Enterprise cluster entry point, and with the URL information and username and password. So now I can just find out where I'm going to push my application to, right? Since we're going to use Pivotal Web Services here, and it tells me how to point the target to this Pivotal Web Services. So what I'll do is I will do what it tells me to do CF login. Now it's asking me which org. And I also see the org information here. So org's just logical division of this Pivotal Web Services. Think about it, it's hosting 60,000 applications, but it's role-based access control. I can only see what I have access to, right? These organizations. So I select number 2 here, and it's asking me which space. I'm just going to use the test space. So space is sub-logical division of each organization. Now I have my endpoint here. I can just go ahead do CF push. One more thing is because my application is going to be connected to Neo4j. So I want to specify that service. I can either do it from command line, or I can just put it in a manifest file. It shows that the name of the application is movie graph, and I'm going to use this jar file, and my service is my Neo4j Enterprise, which I created here by using the Neo4j console cluster on Google with the ID, username, and password. All right, getting ready to do CF push. So what it's doing here when I do CF push is uploading that jar file first to the blob store. It's doing that uploading. And once that is done, it's going to compile that jar file, just bundle together that jar file with this concept called build pack. Build pack has all the frameworks that you need, all the libraries, runtime you need to run your application. You see, it's downloading all the build packs, and it detected that, okay, your application is a Java application. I'm going to use a Java build pack here, right? Java build pack. So now we have a droplet put in the blob store. Then auction is going to happen, right? And we're going to decide which cell, which VM is the one that's going to run this application. Whoever wins that auction is going to go to the blob store, grab that droplet, spin up the container, put that droplet in a container, and run the startup scripts. And because we defined the service here, this is where the service broker is going to create a resource for the application and build that connection between the application and Neo4j Enterprise. All right, so it started. Now if I go here, it says it's up running. So now, I guess that was about a minute and a half. I have my Spring Boot movie graph application in cloud connecting to Neo4j. What if I want to scale things up? I can just say, okay, I'm going to, instead of 1 instance, I want 3 instances. And within seconds, the same thing is going to happen, right? All these VMs going to participate in this auction, and whoever wins is going to go grab the droplet, spin up the container, put the droplet in container, and run the startup scripts. So that was about 5 seconds. Because in production, you can't afford like minutes to spin up another instance. Because that means hundreds and thousands of requests are going to be denied. And I can also do auto-scaling. Because why should we do it manually when we can do it automatically? So if I manage auto-scaling, I'll say the minimum is 1, maximum is 4. Scaling rule, how about HTTP throughput? I'll scale down if there are less than 20 hits per second. I'll scale up if there are more than maybe 100. Save. All right. Did you see that? There were 3 instances, and now there are 2. And in a minute, they're going to be just 1. Because I'm not hitting the application. There's less than 20 hits within a second. All right. So let's go back to our presentation here. We just demonstrated we can write a Spring Boot application quickly and push it to Cloud Foundry and connect to Neo4j. And there's this concept called 12-factor design principles. It's all about how to write microservices in a cloud environment. Everybody's familiar with this, or we want to just maybe talk about several of them? It's basically ensure your application run and scale predictably and in a very scalable way in a cloud environment. So code base is saying 1 code base, 1 repository, 1 CI/CD pipeline, right? That's kind of a no-brainer, but if you think about it, if you put multiple applications into 1 repository, you are coupling them, right? And dependencies is saying you want to have your dependencies in your application. Don't rely on mommy server, WebSphere, or containers to give you those dependencies. Because VMs come and go, containers come and go. Your dependencies may not be there, may not be the right version. They may be different between QA and production. Configuration, this is a good one. We all know we shouldn't hard code our connection strings, right? But let's take a step further. Don't put in a properties file either. Let the environment inject it into your application. As a matter of fact, when we were doing this, so now it's 1 instance. When we were running movie graph in cloud, what was actually happening behind the scenes here is I used Spring Cloud Connector. You see this VCAP services environment variable? So I used that and parse this connection string username and a password and inject it into the application. So I never need to worry about it. I move from environment to environment. In QA environment, I have all the connection string I need at runtime. For QA, I go to production. I have all the configuration I need for production. So there's never be the case where like, oops, I accidentally write production data into the QA environment, or vice versa, right? Backing services, treating your database messaging queues as backing services. I'm not going to go through each one. It's just processes is saying that write your application as stateless, right? Because if you have your session state in your memory, and let's say you have 3-step sign-up process after the first step, your container crashed, and you have that state in your memory, that state is going to be lost. So that's why you want to externalize, store this somewhere else. Store that session state externally, either in a caching like a Redis or external database. And logs is another interesting one. Treat logs as event stream. Write it in a console. Don't write it in local disk. Because if you write logs to local disk, that's just in a container. Containers come and go. You will never see it again. So we want to write to the console and let the platform train it to somewhere else. So in our example, there are several ways of seeing logs. One is I could see logs here, right? You can tell it, or from the command line, I could tell it here, so I have to hit generate a little bit of traffic. And I can see the logs here. But if you let the platform to just drain the logs to the third-party logging management system such as Splunk, you can see all the logs there as well. Admin process is the same. Run your one-off process such as database migration just in the platform as if you were running a long-running process, your applications. So this is our previously tested, very good golden rules for you to run, write greenfield microservices and make sure they run really well in the cloud environment. But what about your legacy applications? We all have to support those things, right? And we want to modernize them, right? So for your legacy applications, if you look at this picture, where are they? Are they on-premise today? Or are they running on VMs on IaaS somewhere? So you want to move your legacy applications to the cloud-native platform, Cloud Foundry, just to enjoy all the core cloud capabilities like scalability. We just saw how easy it is to scale things up and down, right? And then if you are happy there, that's fine. I don't want to keep, we're not going to touch this legacy application often, that's fine. But if you really want to modernize those applications, you can just take one step at a time to move up this cloud-native maturity model. So the idea is for you to do as little as possible to get your legacy apps to Cloud Foundry first. Then at your own pace, you start looking at 12-factor design principles. You look at resilience, microservices architecture, API-first design. If you want to do functions, that's fine. So the transformation, as you can see, is not going to be overnight. It's very gradual, right? It's a gradual process. But you are moving toward a better way of building and operating your software. And we're here to help you become the thought leaders on your cloud-native journey. To sum up, if you want to deploy and operate your applications and services quickly, use Pivotal Cloud Foundry. If you want to store and retrieve connected data quickly, use Neo4j Graph Database platform. Because at the end of the day, it's all about what developers love. Thank you very much. Any questions?